Hello everyone and welcome in today's video. So on the previous question we had this L-shaped frame for which we have to solve by using the force method with hand calculations to find the bending moment at point B, which in the software is going to be node number 1 according to this model. So today I'm going to show you step by step how we can model this frame on Autodesk Robot software, the finite element method software, and in the end we are going to see the results and compare them with the one which we got with our hand calculation to make sure that everything is correct. So without any further ado, let's just start a new project. And as on the other software tutorials, as we explained, the first thing to be done is to define the members and draw the shape of our frame. So the member doesn't matter that much, as mentioned previously. So let's go to see what are going to be the given data, or at least the ones which we assumed. So we said that the load, we can assume it 10 kilonewtons per meters, and the distance A, 5 meters. And this distance A, if we go at the beginning, is going to be the vertical distance. So let's just go back to the software, and now let's just start to model the frame. And this value of A, as mentioned, was 5. So we start by selecting this node and we go upwards. We zoom in a bit to find the coordinate Z at 5 meters. Again, we do right click, and now we have to do the other member, which was 2A, which basically is 2 times 5, it's 10. And we start at point 0, and then we're going to go at 10. So now we model the shape of our frame, and the next thing to be done is to add the support conditions. So the next thing to be done is to determine the support conditions, and to do that we can just quickly go and check what was given. We have a ruler support rotated counterclockwise, and now we go to the software, we click support, and now we choose the roller support. So this one, it has direction 90 degrees. And we need to change this to -90 to go counterclockwise, as shown here. We can override this one. And then we select our node, and then we have our support condition here. Next, let's go and see, yes, we have also a fixed support which is rotated here. And now we go to the fixed support with this data, and if we go to the direction, we need to choose -90 again, as on the previous case. We can override it. And then we have our support condition, which is now rotated counterclockwise according to our exercise. So now the frame is stable, and the next thing to be done before adding the load is to define a load case. We go here at load types, we just add the dead load. We click close now, and now we're going to define our member load, which according to the exercise is a distributed load with value Q. And at the end, we assume that this value is going to be 10 kilonewtons per meter. So now we go to the load definition button here. We go to member load, and now we are going to select the uniform load. The value, as mentioned, 10 kilonewtons per meter, and we need to put a minus here as the positive direction of z-axis is upwards, and the value of the load is acting downwards. We need to put a -10. We add this load, and now we select the bar. So now we have successfully added the dead load according to the given exercise. And now the next thing to be done is to run the analysis. So we click this button here. As mentioned on the previous video, this analysis is taking into account also the dead load of the members. And if we want to remove that, we go to the loads section. And then as you can see, this is the self weight. We right click, and one method is just to cut this one, and then we have deleted the self weight of the members. So now we go again at start, and now we run the analysis again, and as we can see here, we have results which are available. Now we go to the results button, diagram for members, and what we are interested is on the bending moment. At least I prefer these settings for the view. I hit apply, and I go again here to show the bending moment values. So now if I hit normalize and apply, I will have the bending moment at point B on the software at node 2, which is going to be 142.85. which is correct from what we calculated by hand. So thank you very much for your time, guys. I really hope you enjoyed today's video. Please do not forget to like, share, and subscribe to our channel. And if you have any questions, leave them in the comment section below. See you on the next video.